So hello, Dr. Sachinandan Mohanty.
Yes. Hare Krishna.
Welcome, sir.
Yes.
So participants, our two guest speakers are represented here. They are already among with us. So we are going to start very soon. Please follow the chat box. And we have already got some response. So thank you very much. So please in the chat box, if you want to contact with each other, please leave your name, your institution, country, and obviously your email ID. So thank you very much. Our Honorable Professor Celia Shahnaz ma'am, she will be the moderator today. So, and we have two co-hosts from BUET student branch, Sanjana Mahajabin and Shakil Anwar. So thank you very much. So enjoy today's TechTalk webinar series.
Good afternoon, everyone. This is my honor to welcome you all to the first TechTalk of webinar series, Fighting COVID-19. This is SoVEHS Sanjana Mahajabin, Chairperson of IEEE BUET Student Branch WI Affinity Group and Vice Chairperson of IEEE BUET Student Branch. This webinar series is jointly organized by IEEE BUET Student Branch SPS Chapter, IEEE BUET Student Branch WI Affinity Group, IEEE BUET Student Branch, and IEEE Boundless Section. It is my honor to introduce our moderator today, Dr. Celia Shahnaz. Dr. Celia Shahnaz is the senior member of IEEE, fellow of Institute of Engineers Bangladesh, Institute of Engineers Bangladesh. She is a chairperson of IEEE Boundless Section, advisor of IEEE SPS SB Chapter, chair of IEEE SPS Bangladesh Chapter, and faculty member of Department of IEEE BUET. Then I'd like to introduce our speakers today. Today, our first speaker is Dr. Gita Pendharkar. She is a senior educator, School of Vocational Engineering, Health and Science, RMIT, adjunct researcher, Monash University, Melbourne. Dr. Gita Pendharkar is currently working as a senior educator at the School of Vocational Engineering, Health and Science, RMIT, and an adjunct researcher at Monash University, Melbourne. She has lecturing experience of 26 years and has lectured in India, Africa, Australia, and America. She has established interdisciplinary research collaborations locally, overseas, and has contributed to a wide range of journal, conference papers, and book chapters. Gita has received a number of grants for teaching and learning and is a reviewer of journals in biomedical engineering. Dr. Gita completed M Engineering Science on Electrical and Electronics Engineering from Melbourne University and Ph.D. in Biomedical Engineering from Monash University, both on scholarships. She is a visiting scholar at the University of Delaware in the US in 2013. Gita has inspired many local and international students and new migrants from her community to pursue higher education and continues to do so. And she is also the volunteer to present at local schools in Australia and India in order to educate the school students with cutting-edge technology and safe use of technology. Next, another speaker today is Dr. Sachinandan Mohanty, Ph.D. Senior Member IEEE, Associate Professor, Department of Computer Science and Engineering, ICFAI, Foundation for Higher Education, Hyderabad. Dr. Sachinandan Mohanty received his postdoc from IIT Kanpur in the year of 2019 and PhD from IIT Kharagpur in the year of 2015 with MHRD scholarship from Government of India. He has recently joined as Associate Professor in the Department of Computer Science Engineering, CSE, at ICFAI, Foundation for Higher Education, Hyderabad. Research areas of Dr. Mohanty include data mining, big data analysis, cognitive science, fuzzy decision making, brain-computer interface, and computational intelligence. Dr. S.N. Mohanty has received 3 Best Paper Awards during his PhD at IIT Kharagpur, at the International Conference, Beijing, China, and International Conference on Soft Computing Application organized by IIT Roorkee in the year of 2013. He has published 20 papers in SCI journals as a fellow on Indian Society Technical Education, the Institute of Engineering Technology, Computer Society of India, member of Institute of Engineers, and IEEE Computer Society. He is actively involved in the activities of the professional bodies, societies. He has been bestowed with several awards, which includes Best Researcher Award from Bisu Patnaik University of Technology in 2019, Best Thesis Award from Computer Society of India in 2015, Outstanding Faculty in Engineering Award from Department of Higher Education, Government of Odisha in 2020. He has also received International Travel Fund from ACRB, Department of Science and Technology, Government of India for chairing the session at International Conference USA 2020. Dr. Mohanty is currently acting as reviewer of many journals, like Journal of Robotics and Automation Systems, Computational and Structural Biotechnology, Artificial Intelligence Review, Spatial Information Research. He has also 4 edited books published by Wiley, CRC, and Springer, Nature, and 3 authors' book to his credit. Thank you. I'll ask our moderator, Dr. Celia Shahnaz, to take it.
And thank you, Sanjana, for introducing our honorable speaker. It's a great honor that we have today's seminar. We received actually for this webinar series. Actually, today is the first one, and we'll be doing a lot more. And this is the purpose of today's webinar, as we want to really know from the women researchers, women expert, and male expert everywhere, and gender diversity, that what are the research innovation challenges we are facing during COVID-19. It's very important because many students are residential halls are locked down, and we have sent our students to the rural villages, and they have their connectivity problem and other very difficult scenario. In that case, it is our duty to keep them engaged. So with that motivation, we have approached the scholars around the world, and I really feeling glad that we have a lot of experts who actually agreed to contribute to keep our student community, our young faculty community, to remain engaged in such a pandemic situation in terms of knowledge sharing. So, and good news is that we did circulation of the news, and we have received response from all over Asia Pacific, starting from Bhutan, Pakistan, of course, many states of India, and I can see from Sri Lanka, I can see from Thailand, and also Singapore. And forgive me if I could not see, because just scrolling down the list. And during the statistics that we have received also from other IEEE regions, like region 1, region 6, like that. So that's a good thing, globalization. So many people are talking about productivity decrease or other things. But you see, today, the response we have received almost from 10 IEEE region, that is actually increasing the visibility of region 10 technical expert, region 10 student volunteers, region 10 young professional to the global world. This is very, very important. And I'm very grateful that many experts and participants, irrespective of the IEEE region 10, have contributed, has agreed to contribute to today's webinar and to support the vision. So today, actually, we will be hearing from experts who are actually related, because we try to do, because BUET student branch and IEEE Bangladesh section has 9 technical society chapters. Especially BUET is the highest ranked engineering university in the country, where I'm serving as a professor, Department of IEEE BUET. So we have technical society chapters, which is very important to engage the students for the technical activities. So for every day, every webinar, we have set a theme. Today, we are trying to address related to signal processing or related to engineering, medicine, biology, and that's where our experts are coming from. One is coming from engineering and medicine biology background. Another is coming from data mining and signal processing. So in next day, we'll try to relate it to the industrial application. Another day, we'll try to relate it to the robotics and automation. Another day, we'll try to relate it to the electronic device and other things. So in this way, we'll try to cover all technical society area so that we can address the technical interest or need of a huge diversified community. Already Region 10 is very diversified. Since now we are moving beyond Region 10. So we really need to address the need, research need, and the technical need of such a big community. So from today's participation, it is clear that the vision that we have set, that is completely fulfilled. That means we have envisioned something and really we got the response according to that. So it gives us motivation that we are moving in the right direction. So without further delay, let us start with our first speaker, or I can say first panelist, Dr. Gita has already introduced. He's from, in a bigger sense, she is from Australia. So Dr. Gita, and with permission of Dr. Sachi, there is no particular order. Only this, that Dr. Gita has to leave early. It is because Australia is ahead of us. So that's why we are starting with Gita, not really that she's a woman. She has some time constraint. Thank you, Dr. Gita, and with permission to Professor Sachi. Dr. Gita, the floor is yours. You know, hope it is, you understand that why we did it and what is the vision and how our visions are really meeting because of the valuable participation of the technical expert students, faculty members, counselors, advisors from the diversified community. Hope people will like your session. Thank you, Gita.
Thank you, Professor Celia. It's a pleasure and honor to be here. I really thank you for inviting me. And I'm just thrilled to see the number of participants on a Sunday evening who would like to attend and contribute for these sessions. So really worth learning something from you, I think. I would like to share the presentation which I have. So I'm just trying to.
Host, please give her the presentation facility.
It is allowed. You can share the screen.
Yep, okay. Share. Right. Can you all see the presentation?
Yes.
Yes, ma'am. It's visible.
Thank you. So I think Sanjana has already spoken about me. I don't need to go in. I work at two universities. RMIT is my main university where I'm senior educator and faculty at Monash University. My biomedical research is normally carried at Monash University, while as at RMIT, I am the project lead currently for Women in STEM. And so I'll talk a little bit about both the topics and just that what I understand is happening based on the COVID-19 situation. It is a very difficult situation and crisis we are in, I think. Each country is trying to address it in its own way. So yeah, I'll start my presentation. Brief bio, which is already done by Sanjana. Thank you. Bit of biomedical research, my IEEE WI involvement, and then talk about women in STEM. So yeah, along the way, received few awards in Australia, and that is what I've listed in here. Maybe I'll just move on to the second slide. So this was the Women in Industry Award. This picture is, if you recognize this person, he is Rupert Murdoch, sorry. It is, the award was called Keith Murdoch, but it was presented by his son, who is Rupert Murdoch in States at the moment. So that was an American Australian Association Fellowship Award, which I had received. Down below here, this is another national award, Manufacturing Skills Australia in 2011. And this one on the right-hand side below is ISSI, International Specialized Skills Institution Award, because of which I could travel and gain some experience in research overseas. Oops. So my research started, or my research is rather based around assistive technology, wearable devices. I started my research with remote gait monitoring. My first project, which I did, was on idiopathic toe walkers. It was in collaboration with Monash Medical Center. So it's a big government medical center in Melbourne. And that's where I carried out my research. So what was the issue here? The issue was that these children, when they start walking, they should start walking on the toes. And then the reason was not known. Or they had been to the neurologist and checked themselves. They were all normal, no other injury, and so physical injury. So that's why we categorize them as idiopathic, meaning that there was no underlying reason for them to walk. And so then the problem was that eventually, as the age progressed, they grew older, they would get back on the heel, but then there could be some other issues like back pain and so on. Long-term study was not done. And so that's where we went in and we developed some kind of instrumentation which recorded how many steps the child took on toes and how many he had normal steps. And this was back in 2003, where we didn't have the wireless technology established as such. So it was all kind of wired, a memory chip and with a microcontroller and so on. But however, we did it and we got the results. And so then that was continued further down using the wireless technology as well. The other project I looked at is gait monitoring in vestibular disorders. So with vestibular disorders, what happens is that a person just feels that he's not got a stable maybe gait. So when he gets up or when he changes his position, apparently he feels like it's all rotating. He feels very giddy. And so then what they wanted to know at King's College London was whether it's really affecting the gait. And that's where again we designed a system and we tried it, and then they carried out the study clinically. So there are a few other projects which I had worked on in Melbourne, Victoria University, so these are the sensors, the orange little boxes, MTX sensors. And again, they have got accelerometers, gyroscopes, and so on. And to look at how we can actually analyze the exercise pattern in Parkinson's while these sensors are mounted. Idea was that all the Parkinson's people, because they lose the muscle strength, they have to go to the clinic. And then that's where they are monitored with the exercises. But can we have something at home for them? And that was the idea. So that's where we had done this particular research. At University of Delaware, I had developed the boots which could track the gait in a particular person, and they actually built this robotic exoskeleton. So what I wanted to check was that using these boots, I wanted to check, is it affecting the gait? This exoskeleton was used to train the people who had lost the particular gait. Okay, so what I wanted to check was, after putting on these boots with that huge exoskeleton, when it's connected to you, are you feeling normal, or it's like actually you have to put in some force to move your legs forward? And that was the research I did and published it as well. The current research is again in a very different area. So one of the research I would like to mention is predicting the early stages of drug-induced Parkinsonism using machine learning. Parvati Nair is my student at Monash IITB Academy, and she is in Mumbai at the moment at IITB. So what happens is, the experiments were done in Melbourne, that these particular people with mental disorders, with, say, for example, schizophrenia, they are given certain drugs. Now, the drugs are categorized into first generation, second generation, and so on. So what was the theory or the research says that those who were given the first generation drug, they developed symptoms of Parkinson's disease. So, and shaking in the hands and so on is what they developed because of the drug which was given to them. And that was a study we wanted to really figure out, is that what is happening? Then we also did the experiments on the second generation medicine, and we tried to compare the two, and it's still continuing. The first study, what we did, and the pilot study, we got really some good results, and we could prove that using the accelerometers or the sensors, it does tell the clinician that there could be some chances that this person is developing some kind of Parkinson's symptoms. So that could be an indication. 100% it cannot be proved, of course, but yes, it does give an indication of that. The other project, Radhik, who is another student of mine, is working on is pediatric robotic surgery. The problem here is that the current robots, which are there, Da Vinci and few others, only cater for adults. The instruments, what they have, what really, which is inserted in, is has got a thicker in dimensions and doesn't really help young children. So the question here was, can we actually minimize the dimensions? Can we make it smaller and cater for younger children as well? And this research is in progress, and he's still working on it. And it's not just one project, but there's multiple students working on this project. So I would like to just conclude my biomedical research here by this particular saying. I love this from Albert Einstein. He said that I fear the day that technology will surpass our human interactions, which is what I kind of feel is a little bit is happening right now. And then he says that the world will have a generation of idiots. I kind of doubt that. I don't know. But for me, being a biomedical engineer and looking at the artificial intelligence and what all things are going on, I fear the day when people will actually start using the technology to control each other's brain. And I think that's not too far. So that is quite possible. And I really fear there. Okay, moving on to, so last 2 years I've been quite involved in the STEM research, and particularly looking at women in STEM. What are the issues in there? How can we actually solve those problems? And this started when I was invited to Berlin by the Diversity and Inclusion Committee to present in the opening ceremony. So I was there last year, and that's where I met Kanita as well, who introduced me to this particular group. So if Kanita is there, thank you, Kanita, for that. This was a saying which was put up by one of the committee members. Diversity is being invited and inclusion is being asked for a dance. So really makes sense in there. So people just say diversity and inclusion means the same. No, it's not. Diversity is one thing what we are addressing, having multiple, as Professor Celia said, having number of people. But then how do you know that you have made them, you have included them? Is you're really inviting them? For example, today, we all are being slowly invited to present, and I really appreciate and love it. So this is what inclusion means. So we all need to be looking at that. This was just a photo taken. This is Shankar, who is the president of EMBS Society. And this is my colleague Azadeh, who is currently the chair of the Diversity and Inclusion team. So that we know the number of advantages and the importance of diversity, and which brings in cultural intelligence and so on. So we are trying to address number of things by looking at the diverse and by having diverse teams at even EMBS, for example. Moving on to Australia. Australia is really suffering with not having more number of women contributing in engineering side. So, and that's one of the major worry here for the government. It's not just in Australia, it is overall, even in US, even a lot of the developed countries. So we are trying to look at what are the problems. And so if you can look at the graph, it's kind of come up to a plateau and flattened up there, not going anywhere. Just some of another graph showing the graduates in engineering as the men and women ratio. Also looking at the pay gap in men and women in number of areas. So that's also not a good thing. So there are a number of factors which are contributing to this particular difference. Now in here, I'm in my role as project lead for Women in STEM. I'm looking at, I'm trying to find out what are the issues. And again, we all know it's not just a simple question to answer. Not just one mathematical model or AI algorithm is going to work, which is going to solve this Women in STEM problem. It has taken decades to build up, and that's how this is built up. This issue has come up. So now, of course, to solve this problem, we will need many years. And to see the actual results, we are going to see many years as well. So, but what I can tell you is, don't know what is happening around here on the screen. If you're, yeah, okay. I was just looking at a report on what's happening with women in STEM, and this is particularly with Australia, and what is the impact because of COVID. And so it is indicating that women are facing some disproportionate increase in caring responsibilities due to maybe domestic work and so on. And so, and especially, oops, I don't know what is happening around. Yeah, and so, and this is seen mostly with women who've got children, young children under age of 12 and so on. So I believe COVID is going to take us back perhaps another 5 to 10 years in terms of research for women, and that too in STEM areas. Because, and who is to blame? Is that right or wrong? These are all real difficult questions to answer. First of all, the economy needs to be addressed, and which is the most important thing. So obviously that comes as a priority. And then the women in STEM, but knowing the fact, knowing that this is an important thing now, knowing that we want the women in 50% equivalent in similar way as men to contribute, knowing the advantages, what women bring in, I believe we should be able to fill up the gap post-COVID soon or sooner as compared to it earlier, took a bit of time. So I think I've spoken a lot, and thank you very much for your attention. Thank you.
Thank you, Gita, for sharing your wonderful contribution, especially your work for, I should say, I don't like to use the word disabled people, because we are here to make them differently abled people. Then how we will make them differently able? By our technology. The way you are doing that, you are applying your engineering and medicine knowledge, you are applying your robotics knowledge. Actually, that's a diversified community. Thank you for your contribution. If you have any question, please write it in the chat box, because although it is COVID and data of COVID is very difficult to achieve, but not really, we have to always work with the COVID data, because there is a challenge and process in getting the COVID data. But in whatever capacity, to the best of our capacity, we can think and we can brainstorm ourselves this COVID situation so that we can create impact in the community. So any questions, Sanjana, in the chat box? If you have any doubt, please write in the chat box. It will be great if we can hear from.
There is a question in the.
So Gita, now since we are getting time, can you explain a little bit better about your about more detail about your assistive technology, so that the students get encouragement for working on those topics? I remember, because I'm the founder of Special Interest Group on Humanitarian Technology site in Bangladesh in 2013, and our first project was assistive technology for the autistic children. In the whole Asia Pacific, 17 proposals were submitted to Humanitarian Technology Committee, and 4 were supported, and our project was one of them. So I am very much interested to know, I think same for the audience, explain a little bit so that they can brainstorm during this COVID situation. Thank you.
Yeah, thank you, Celia. Happy to talk about the assistive technology. So when I say assistive technology, again, my research revolves around gait analysis. Gait meaning the way you walk. And there could be multiple reasons. We know that people who have got stroke, people who suffer Parkinson's, idiopathic toe walkers, or toe walking because of any other reasons, they all have got different gaits. And I also say that each one of us have got a signature gait. We all have got our own different style of walking. If that can be captured, and how would you do that is what essentially I was looking at. Not only the algorithms, artificial intelligence and so on, but even hardware wise, as the new chips come in and new sensors come in. So what and how can we use them in order to have accurate gait analysis done? Was contributed a lot to my research as well. Developing artificial boots, again using simple sensors. The sensors are really tiny. The systems, again, to make them really compact is a big challenge. Then wireless technologies, which one would you use? Because there's a number of wireless technologies available. So depending on the need, again, you have to kind of come up to one particular technology. Can you use Bluetooth? Do you need to use RF? Recently, we were looking at RF for gait. Does it work with antennas and so on and so forth? So, and that's where my research revolved around. So we also used some kind of fabric, so e-textiles, where we had the what do you call that, conductive threads, which was just, you know, a resistors material and so on. So that was another project which was done by a student. Again, wirelessly, that band could be worn on and the person would walk, and then using MATLAB, it would give you a user interface where it would kind of give the clinicians all the parameters of gait, stride, step, etc., what a frequency and so on. So these are some of the really simple projects distinguishing between running and walking, which is one of the most important area in sports technology as well. So gait in not only medical side, but can be extended to the sports side. Medicine, of course, being the priority and the need, but sports also being another area which was looked at. So this is what we kind of looked at.
Okay, thank you, Gita. So important takeaway for a general students who are not doing signal processing, medicine or biology, but important takeaway that gait is a signature of every person. So it is your signature and my signature. So this is an important biometric identity that can create and make a difference between the two people. So that's very important thing for the people who are still becoming interest for signal processing or machine learning. So this important unique biometric feature we can use. We have one question. We will take question very quickly. What is the cure rate of Parkinson's disease? You don't really give exact response, but if you know, just share your idea. What is the cure rate?
Look, the question is very broad. Cure rate for Parkinson's disease. I mean, is it in terms of medicine or in terms of, because my research was just, first of all, without, knowing that the person has got Parkinson's, can we actually just monitor and figure out that they have it? So yeah, monitoring was one of my research. So cure rate, I will not be able to answer that question. Sorry, that is up to really the doctors to let you know.
Yes, it's a very wide question. So another question, and the first question was from Nikita Agdala. So actually, when you are writing the question, if you could write your country, your section, that I could introduce you better, I could recognize you better. This is not, we are listening. It should be interactive, and we want to recognize every person here who is asking question, and he or she is a contributor. We want to recognize him or her. From Vishwajit Jana, our question is, nowadays research is going on using exoskeleton on paralysis people. What is your opinion and the success rate on it?
Yeah, good question, Ms. Vijit. There are lots of exoskeleton being used for people who have got paralysis, and I think it's one of the platforms which is going to come up eventually, because exoskeleton, especially with people with paralysis, they do not have strength in the muscles. So depending on which part of the body is affected, they might be able to use the exoskeleton. I heard a story where a student in New Zealand could attend his graduation because he was given the exoskeleton and he could walk because of that. So I definitely see a big future in there.
Thank you, Gita. We will not take many more questions. If we have more questions, there is a general question from Catherine, South Australia. Thank you, Catherine, for asking that question. Do you think we might see an improvement in women's participation in STEM after COVID if employers embrace flexible working arrangement, or do you think we will end up doing even more housework? And it's a very tricky question. It depends on policy making also. So for your kind information, before Gita moves, our Women in Engineering student branch that is led by Sanjana, and the advisor, I'm the faculty advisor and founding advisor. Our Women in Engineering student branch, BUET, became the best WA affinity group in the whole Asia Pacific, and not only that, it became the best Women in Engineering student branch affinity group in the global IEEE WA. I really appreciate the team's effort, and also as advisor, it is a privilege to mentor them, okay? So this is good information, and that best group is organizing it, and we are having Gita, and at the same time we are having Catherine. So important platform, and that is a three combination, the best group, one of the best expert, and one of the best and inquisitive question setters. Go ahead, Gita.
Thank you, Celia. You have really made us all look so good. Well, really, I don't know if I'm the best. We just try and do as much as possible. But it's a good question, Catherine. And I think Celia would be able to answer that. But being in Australia for so long, maybe, I think you have got a valid point. I think if we are smart enough in Australia, the industry people will take advantage of the fact that now we can provide flexibility. So let's keep this job opportunities open for men and women both equally. And hence, there is a possibility that there will be really good job opportunities for women in STEM. I can already assure you that a lot of people, industry have approached me and they're happy to have women employed as well. So on one side, I have this feeling that yes, this is good, and it will open up a lot of opportunities for women as such. And let's hope that. Only thing is, I would say, as women, we need to stay strong and tell our counterpart that yes, the household domestic work now needs to be distributed, because you know what, I'm going to go to work as well. So you need to do half of the bit. We need to be strong enough to say that. Thank you, Catherine.
Thank you, Gita. Thank you, Catherine. If we could get more time, that we could discuss more. Now in one point, I have seen more than 111 valued participants were there. Before people start dropping out, with permission of our next speaker, Dr. Sachi, let us go for a photo shoot first, because people may leave for another meeting, and then we'll start our another very important topic, and that will be more interesting. Dr. Sachi, we are waiting for your discussion.
Yes.
Okay. So we covered today because region 10, because still I'm residing in region 10. Region 10 has South Asia, India, Pakistan, Bangladesh, Sri Lanka, Bhutan, and region 10 has Southeast. We have from Southeast Singapore, Malaysia, Indonesia. We have participants from Indonesia, and we have North Asia like Japan, Korea, China, and we have Australia and New Zealand at different zone. So we have represented Australia and New Zealand today, and we are also representing the South Asia by Dr. Sachi. So Sanjana, go forward for a photo shoot, then we'll come back and listen to Dr. Sachi.
We're requesting everyone to please turn on the videos, and we will take screenshots.
Some people are trying to admit them first. And I request everyone to write in the chat box, please write your details and rename your profile, like Celia Shahnaz, Bangladesh, right? Something, Shomia, Australia, like this, so that we can know you. So Sanjana, please say ready and go page by page.
Sure.
Gita,
Sure.
we cannot see you, your video. We are taking the photo.
Okay. So I'm taking the first photo. Everyone ready?
Yes.
I'll be taking consecutive photos. Please, everyone stay still. Last one. Please turn on the videos, those who haven't. There. Okay, we are done with the photos.
Thank you, Sanjana, for your effort, and thank you everyone for cooperating us. It will be a memorable moment for all of us. We'll try to send this to you. So with that said, let us move for Dr. Sachi So, Dr. Sachi, you have been already introduced. So, if you want to share something with us, you're most welcome.
Okay, kindly allow to me share the slides.
Sanjana, please help him.
The participants are allowed. Sir, would you please check if yes, sir, you're sharing the screen now. You can show that. Yes, it's visible, sir.
Now it is visible?
Yes, sir, it's visible.
It's visible, yeah, okay. So, very good evening to all, Hare Krishna. So, I would like to thank Dr. Celia Shahnaz, Professor, Department of Electrical Engineering, BUET, and Chairman of IEEE Bangladesh section, to invite me to deliver a talk, technical talk on webinar series on research innovation challenges during COVID-19. And my topic was emotion and mood state and information processing and pandemic based on the time series analysis. So I hope everybody fine.
Dr. Sachi, can you move a little bit closer to the microphone? We need a little bit louder.
Okay, so is it audible now?
Yes.
Okay, so I hope everybody fine and safe in this pandemic time. So on the basis of my presentation, so I'll be discuss. This is a research article. We have ongoing process with the help of Professor Xinjiang, China, from the Nashing University. So this is my plan of presentation. Introduction, related work, methods, result and discussion, conclusion and future work, and the reference. So what is emotion? Emotion, every human being, every living being also is emotion, right? So emotion and mood state are very close each other. So I'll give you one real life example rather than the theoretical definition. Suppose you driving a car and inside the car, suppose you are enjoying by listening the music, and in that road no one is there, you just average speed you are driving the car. Suddenly, so for the time you are enjoying by watching, listening the music, suddenly one vehicle overtake you without giving any pre-indication. So here what happened, the moment a particular vehicle immediately, very speedily overtake you, suddenly what happened, you become fear. So just few seconds you are enjoying, immediately it will become fear, anger come to mind. So in this few seconds, the three disorder in your mind, first is you are happy, then immediately anger, then immediately come to first happy, then come to fear, then come to anger. So these are the positive emotion and the negative emotion. So these are the positive emotion initially, immediately convert to negative emotion. As per the Watson and Clark scientists in 2008, they proposed human emotion is two types. One is positive, one is negative. And the positive also classified different category. What are they? One is interested, excited, strong, enthusiastic, then inspired, then attentive, active, these are. Now, what are the negative? Negative is distress, upset, guilty, hostile, then ashamed, fear, jittery, these are the negative. So what is emotion? Emotion basically in your mind, in your body, based on the cognitive part. Emotion and the mood state are the both cognitive part. So emotion oriented in nature and do not long for the long time. Suppose you got some money suddenly from prize or award, the emotion will be become happy. But the mood state will take the long term, and emotion always the short term in nature. In epidemic situation, public opinion has a many significance, such as communication, economic policy, and education and health issues. So, in case of first one, it has many significance. First one, it can assist the opinion of the public. It can assist the government to implement precise policy and alleviate social panic. During the times of public crisis, government must be swift to communicate crisis information effectively and efficiently member of the public. Second is the economic policy say that formulate appropriate isolation measure for the changes in public sentiment, reduce the social problems and reduce various conflict caused by the public unrest. Thirdly, formulate corresponding economic policy stimulus emotional change to promote economic recovery. Fourth case, in case of provide-based university family school opening the education sector, university formulate the school opening policy and adjust the school opening time in case of during COVID situation. And finally, the health case, these findings can help to government, to health department, better communicate to the public on health and translate public health needs into practice and create a target measure to prevent and control the spread of COVID-19. So these are the different aspect we can discuss one by one, and these are the what are the we have find out as a current scenario. These are the major factor we have to consider as a decision. Now, recently literature suggests that in 2018 and 19, they suggest that most of the important factor by using social network analysis when the application program interface and related to work divided into two parts. One is a data crawling and the sentimental analysis. Our part based on the sentimental analysis. So from the data, what are the public spread in your social media, either Twitter or Facebook, and the Japanese social media we call the web tech. So from the data we collected and we identify in which time period the public, what are the different type of mood state. So methods we have considered. So one is called the machine learning based method, one is dictionary based learning. In case of dictionary based learning, so what we'll do in methodology, first text mining. So this text mining means we collect by the data from clear frame selection, and in that selection we have used the framework. The framework is nothing but Scarpy Redis Bloom filter. So what is the Bloom filter? This framework basically use in general extract the web information data. So again I'm saying Scarpy Radius Bloom filter is the framework through which we extract the web information data. And the Bloom filter basically apply to reduce the memory consumption. Then after collecting the data, the system can judge positive and negative emotion of the reviewer based on the comment and also reflect the depth of the 7 emotion. We've considered the 7 emotion, and the depth of the emotion also identified. And what are the depth of emotion? One is called the hopefully, happy, and depressed, like that. Finally, we improve the sentimental discriminant model of this study and compare the sentimental discriminant of the COVID-19 related comments with a different type of model. These results show that, our results show that model has a better generalized ability and smaller discriminated error, we design a large data visualization screen. We can clearly sort and publicly emotion and portion the various emotion categories, keyword, hot topics, etc., etc., and fully intentionally reflect the development of the public opinion. When come to the next slide, so I will tell you how this model will be work. This model, what we did first of all, do the text mining. So this text mining basically we calculate from the popular, we extract the data from the public tweets, COVID-19 topics, and some web. So this website is called the one of the, like in India we can call the different type of Facebook with Twitter. In China there is called the Webic, right? This is the they can source the data. So here scape data is filtered, distributed clear framework is main overflow, and this scheme masker we are using. After that, what happened? New popular SAP media, official SAP media, popular what are the media are there, we extracted, and this extracted data we can find in the SAP group. And this distributed clear framework basically use the number clearing level exceed 100 millions, and radius will be occupied a lot of space. At the same time, radius will be also occupy the memory, the storage, the clearing queue. For that, we're using the Bloom filter algorithms. When coming to the next generation, so after extracting the text data, we find the purifying the data and identify who are the outlier, we are removing the data. Then one observe and consider the BEMS. So what is BEMS? The status of this locate at the beginning, locate at the end, locate between the verses, the particular word, and separate from the words. So these are the single word we observe. Then find the weight matrix of this BEMS, and finally the weight matrix will be identify what should be the observe and what should be the status. So on the basis of observe and status, we collect the different type of phases. That is called the status 1, status 2, status 3. Then finally we got this type of data. Then what is the step we are using? Establish the microblog comment sentimental directory. Then the text will be pre-processing, and then develop a model, then subdivided emotional particles. So 7 subdivided model we have used. So these are the analysis result. This sample, these are the China I have written. My co-author, they provide all the data. I just support for analysis part and writing the manuscript. So far this manuscript is not submitted with the words of the submission. Then finally, what will do? Custom sentimental directory and general sentimental directory. Custom sentimental directory we have to create. General sentimental directory already existing in the map sentimental. Then after that, what will do? Work plan of the experimental setup. Extract data from the Weibo. Weibo is nothing but the microblog website that used by the China only. Analyze the data by using cleaning, outlier detection, remove, and the normalization. The normalization means suppose the data is given 1 to 100, you want to data normalize 1 to 10. So what will do? The 100 will divide by each number. So automatically that will be normalized. Then first the web page, then extract the text information. And these are the workman. The experimental setup we have used hard disk by system by using 120 GB, graphics, NVIDIA, because it's a lot of processing is required. Operating system we are using Mac, bandwidth we are using the 2.5 GPS, otherwise download data is very difficult, and RAM using 16 GB, memory type will be this one. So in this is the flow diagram I mentioned how to do it. So the results say that you see the 7, these are the different type of, we find out through the positive, negative, hopeful, happy, depressed, angry, and frightened, disappointed, and shocked. You see, in out of this, we'll identify, let me clarify more in this case, result analysis, what we have observed. As of now, there are 2 kinds of emotion, positive emotion, negative. So here I mentioned this is positive and negative. But positive and negative alone are not enough to express the people deeper emotion. This experiment further refines the emotion of Weibo user and subdivided by richness, base the positive and negative, come upon the 7 detailed emotion like hopeful, happy, depressed, disappointed, angry, and frightened and shocked. And through the data analysis, the number of WIBA users and the promotion of each emotion, we can better understand the deep emotion of the blog user. So here, total number of tweets or total number of comment we consider 1,94,3,026. Remember, 1,94,3,026 posts we have collected. If you compute this total, how many shocked 1,3,322, how many disappointed 4,6, these are the shocked comment, these are the disappointed comment. So I'm very, very unhappy. This is disappointed, right? Then angry 2,193. What COVID will help the life? This is angry. Then disappointed 1,3. Then these are the happy 2,1,325. So these are the hopeful. The coronavirus will be up to stable up to 2020 like that. These are hopeful messages. So these are the messages will be identified. So total number of tweets we can call the post comment 1,94,326. And the different comment also we can identify. Out of different comments we can analyze. So total is equal to 1,920,326. Then different part of the often can different effect. We can choose the verb, adjective related to name, country, and institution name. User regarding COVID-19. Adjective can be based on the expression of emotion and will be users. And some also on security aspects, some data also get eliminated. Some data is not related to this COVID comment, so that way we can not consider that data. And such as user concern epidemic situation in various countries of the world we can consider. Then finally you can see in this diagram, so I pointed out here some data you can observe the comparative of analysis to the help of existing model. So here comparison in the percentage of user emotion classification in the specified period. These are on the basis of random sampling. These are on the basis of random sampling. You find most of the candidate, most of the individual having our emotion monitoring system are happy. Though we have comprehensively observed that experience method, many excellent Chinese sentiment and analysis mode design set of discriminant process of the system. Sentimental oriented potential wise mutual information is the one of the algorithm we implement to get this data. And out of 4,000 comment will be used the data cleaning and the controlled experimental would be calculated. From this you see here the maximum data is equal to 114. So this 114, there are in 114 the 7 deeper changes in positive and negative emotion cycle we have analyzed. The change emotion cycle from the 7th period of COVID-19 from February to early to April 2020. And from February, mid of the February, you consider from suppose 3 to 18, suppose the mid of the February is suppose 15, so 15 lies between 3 to 18. So mid of the February to April 2020, most of the people are becomes hopeful. So clearly 7 changes of emotion, and we can judge the public opinion more scientifically and effectively. We can observe mid of the February people have become more and more positive in face of COVID-19 and their negative emotion be gradually declined. See, this is our objective. In conclusion work, you see we have designed the COVID-19 in public opinion and emotion monitoring system based on the time series model, because every data become changing, so that's why you using the time series model. Our system has innovative attempt. The characteristics of COVID-19 public opinion communication with improved dictionary construct method. We can classify the discriminant according to benchmark positive and negative emotion, conflict the map emotion, the deep emotion. Then our system has a following another major important is that insufficient of the data also beat the Chinese word segmentation directive. This work is based on the Chinese directive only. When central directory cannot directly effectively classify the deep emotion of the test, we can classify discriminate accordingly to the benchmark of the positive negative emotion, confidence map emotion to deep emotion to achieve indirect classification. Another experimental results show the sentimental discrimination with life system of the 7 positive sentence. And what are the future work considered? We have integrated some excellent online Leximo, emotional Leximo further expand in the corpus is a database where all the test data are there and improve the accuracy of the system discrimination. Then finally, at present our experiment has trapped 1,526 hot topics and 242 hot comments. However, this more number of comments, more number of hot topics may be analyzed in the future. And finally, the good dictionary can be enhanced in efficiency of word segmentation and improve the generalized ability in terms of accuracy, recall rate, and the accuracy of the model. And the future case, we can compare our existing method, our result with the existing method. So we try to better model so that public, so society, to contribution to the society. So these are the list of reference, the recent reference we've identified. So most of the articles. So any questions from your side?
Thank you. Thank you, Dr. Sachi. So much interesting work and related to the current COVID data. I usually started working for emotion recognition from voice, then emotion recognition from image, then emotion recognition from audio visual. So it's closely related to my heart, but you have created an impact because you are starting the research, you have addressed the research related to emotion and mood detection during the COVID pandemic. So participants, please write any question to Dr. Sachin because it is a very timely topic and you hope you have already get inspired to start thinking, analyzing such mood and emotion with your local data available. So actually it will open up a new repository for us. We can collect such data from different countries and this platform can be used to gather that information from different countries, different locations. Then Professor Shoti and myself can help you to guide doing such analysis from different countries.
Hello.
Isn't it, Dr. Sachi?
Hello.
Yes. Yes.
Hello, this is Radhik from Chennai.
Yes.
Yes, sir.
Sir, actually, I have data for image analysis of CT images.
CT image, okay.
Yeah, CT images based on COVID-19 patient, coronavirus patient. And how do you do analysis with the help of neural network?
Okay, so first of all, CT image we are telling basically lungs image, right? Am I correct?
Yeah.
Long.
Lungs images.
Okay, so first of all, what we'll do, as per my opinion, you identify what are the major factor. What are the major factor from the imaging? So CT imaging, what are the major factor are may be used for the decision maker whether it is a COVID-19 disease or not. So what are the image you have considered? All are the from COVID positive or some random image you have considered?
No. All the images collected with the help of positive patient only.
Okay, positive. So your objective is you do identify how the using neural network on the basis of you develop a system so that the image will be input, you will give the positive or negative, right? Am I correct?
Yeah. We have to confirm. How do you?
Dr. Sachi, I want to interrupt. Actually, the question setter from Chennai I like to guide you. Maybe your data does not contain only COVID patients. It should also contain some normal patient also.
Yeah.
Otherwise,
Mix.
there is what's the use of using this data mining technique to find whether the X-ray or CT image is from COVID or not. Please check with your database. It must contain some normal also. Otherwise, if your data contains only CT images from
It will
COVID,
bias. It will bias decision.
then you cannot do it.
Oh, whether it is possible to apply convolution neural network CNN
Yes. Why not? Yes.
algorithm?
It will be more efficient CNN.
Ah.
It will be more work. Otherwise,
But we have to
LSTM
compare
also
with the normal patient and also with the deceased persons.
Yes.
Positive cases. Okay.
Your problem is a by-class problem.
Yes. Your data should contain both
Both.
normal patient and COVID patient.
Okay.
Otherwise, there is no use. It is as Dr. Sachi said, it is a two-class classification problem. Right, Dr. Sachi?
Yes. If you consider all the positive, that is means data is biased, right? So everything is positive, right?
Okay. Thank you.
So,
Hello, sir.
Any question?
Hello, sir. I'm Aditya
Yes.
from IIIT Kottayam, sir. Currently, I'm working on a project in detecting brain tumors using MRI images, sir.
Okay.
Currently, I'm facing issue with bias signaling, sir. So, which neural network helps me to get the results within short time?
So my suggestion is go for network. Otherwise, you go for Hope Field neural network. Note down. Better to go to Hope Field neural network because Hope Field network could given the threshold value -1 to 1. So in this case of activation function, you use let's say 0 and 1. Don't use -1 to 1. Use 0 to 1. Then after that, a set of same image, you using a -1 to 1. Whichever give the data is more accurate, you prefer that one.
Okay.
First of all, you write down the Hope Field neural network. Otherwise, you use the LSTM with a CNN deep learning neural network.
Okay.
Auto uncontrolled also you can use, no problem.
Okay. Thank you, sir.
So, any more question?
Yeah, there is a question. This is Professor Prabhakar Shrimali from Delhi.
Okay, yes, sir. Hare Krishna.
Please tell your affiliation.
I am a professor with GV Pant Government Engineering College, Delhi.
Yes. Tell me.
Yeah, Dr. Sachi, regarding the previous question regarding this CT of COVID patient, madam said that it is a two-class classification. So instead of going neural network, what about using this two-class classification? You have SVM classifier. What about using SVM? How do you compare SVM with neural network?
Okay, so you see, this is a very good question. So what I want to say with my expert knowledge. First of all, whatever data you consider, so there are different type of bioinspired algorithms are existing as of now, right? In India, concern what happened in India scenario, so data is already there, methodology already existing. You just compare and find the publication, right? Here there is no innovation things are there. So my suggestion is that can you use any hybrid method? Suppose you apply the support vector. Support vector machine is already used from 1986. So as you saying that you can say that I can use support vector machine. Someone say that I can use the DNN method. Someone using I can use the auto encoder method. Okay, you can use, no problem. So thing is that try to do some innovative work without using some existing word. Can you use some own method? So support vector machine is already there, right? Can you develop a own method on the basis of what exactly input parameter is there and what exactly your output? So there must be output input relationship. You will get the decision state, right? You get the decision shape on the basis of neural network. Same things happen. input-output relationship, you get the output. So my suggestion is that you can use the support vector machine, no problem. But support vector machine is a very old method, right? You see in the recent literature, you want to publish, you want to submit an article in very good journal, they have criticism, you will get many criticism. This is what is your innovation. This is already existing. Data is already available. So what is your role?
I'm sorry, Dr. Mohanty, probably I could not put the question correctly. My question would be...
Hello. Actually, we are passing, we have already passed our time.
Okay.
The
I'm sorry.
question that you have, you can write it in the chat box. I will send it to the Dr. Sachi, okay? And we'll try to communicate with you.
Okay.
So actually, we recommend everyone to write in the chat box.
Okay, I'll
so
do that.
if there are no more questions, then we have to close the session because tomorrow at the same time we have another tech talk, and